So hello guys, welcome back. So today basically I found one Allen paper, like there was an All India online test series recently on JEE Advanced. So I have got that paper, so I guess we can discuss the questions. So, and guys, one more thing, like before beginning on with the video, just one more thing, like a small request. I saw the stats recently on my channel, and I saw that the like subscribers count and all, they have really decreased. Okay, so I don't know like what is the problem. If any problems are there, you can reach out to me obviously, but guys, it's a request, like please keep supporting, because if it goes downhill, then I won't be able to continue further. That is the problem, because due to personal reasons. I hope you can understand. So, anyways, and one more thing, guys, like this feels like a huge achievement for me. In like you can see, if you can see on the screen right now, this question is number 2. Okay. So, in that particular paper, the first question that was given, it was actually one of the questions that I had done in my previous video, just I guess 2 months ago. Okay, like if you have watched my first, I had uploaded, I guess, one Putnam video, Putnam questions. So if you go into that video, you will actually find one question where it was FD, like a series of differential equations was there, F dash GH, F G dash H, and F GH dash, and there was a whole lot of manipulation. Like it was a difficult question, okay, from Putnam. So I had brought in that question and solved it. So basically Alan had given the same question in their test series as the first question. Okay, so it sort of feels like an achievement. And one guy also like messaged me on Telegram that he had seen that question on my video and so he could solve it. So that feels like an achievement, guys. Really proud. Anyways, so guys, this will be the first question, and let me tell you the two questions that we are taking are outstanding. Okay, this question will be the first one. This is a question on permutation combination, and this is outstanding. Like you need these two questions. Like I like this paper really. It was a very good. The level of the paper was very good, and the two questions I am taking, actually the second question I had given in my poll. So if you have still not solved it and given it a try, then exit the video right now, go to my channel. In the post section you will get one post there where I had posted the second question for today. Try it once. If you get the answers, very good. If you don't, then come back to the video. Okay, so I guess guys that was enough of some talk, so we can start off. This is the first question. You can try this out, a very good question. I will pause for a few seconds and then go on with the solution. Okay guys, I guess now it's time for us to solve this. So basically, if we give a reading to this question, we have to consider all 10 digit numbers formed by the digits 0 up till 9 without repetition, such that they are divisible by penta 1. I mean 5 ones, okay? Like 4 1, 5 1, anything like that. 5 9 also will encounter. I am telling that as penta 9, penta 5, okay? Then we have to like find out these options. Like broadly I can analyze the options and tell you that one question is we have to find the total number of such numbers, and another question is we have to find the smallest and the largest possible number. That is broadly the question. Okay, so I guess we can start off. So first thing that we are going to do is we will let the number that is being talked here, 10 digit number, as capital N, and let this be x1 x2 x3 x4 up till x10. This is your number. This is be such a number. And here you can understand, I guess, x1, x2, x3, these are the different digits. Now, if we go on to your sigma xi, like if we try to find out the sum of the digits present, then obviously you can understand like the digits are without, this is also an important state, like pair of words, okay, without repetition. This is a very important word in this question. This not being mentioned, this question would have become twice as difficult. Okay, very important word, without repetition. It actually means that x1, x2, x3, x4 up till x10, all of the each of these digits are distinct. So if you choose x1 as say 9, then you can't choose x2 up till x10 anything else again as 9. It will be 0 to 8. So basically it is actually the sum of xi in whichever way you take the numbers, the digits. The sum of xi will be the sum of first 9 natural numbers. Like 0 is a whole number, but we don't need to take that. So first 9 natural numbers, which is your n into n plus 1 by 2. So this thing comes out to be 45. Right. And now if you see one thing, like if the sum of the numbers is 45, then in your very small classes you have learned a very small chapter which is called tests of divisibility, which I hope you remember right now. If you don't, then you are doing a pretty good mistake, because tests of divisibility is something that is very important in your permutations. So if you have, like, this might seem a little funny, but if you still don't remember your tests of divisibility, then please go on into your class 3-4 books and revise them, because they are really important. Okay. Anyways, 45 is the sum of the digits, and so from test of divisibility of 9, we know that when the sum of the digits is divisible by 9, the number will be also divisible by 9. So n is divisible by 9. Now this is what we found, and one more thing is given, that n is divisible by penta 1 also. 1, 1, 1, 1, 1. So if we actually take the LCM of these two, we can say that capital N is divisible by penta 9. Right? Pretty obvious. So now using this thing, we will actually try to form something from capital N. Okay. So I am changing the page and writing. So now actually I will do the most important step, that is I am writing capital N as your x1, x2, x3, x4, x5, and let's leave these 5 digits apart. So I want to write the next 5 digits separately in form of a sum. So to do that, actually I have to multiply this with 10 power 5. So you will have 5 zeros, and in those 5 zeros you can fit in your x6, 7, 8, 9, 10. And now what we can do is, I can write this penta 9, the 10 power 5 as penta 9 plus 1. Right? So what we can actually do is, I can keep x1, x2, x3, x4, x5 into penta 9 in one bracket, and take this thing x1, x2, x3, x4, like there was a plus 1 also. So that plus 1 will come here as x1, x2, x3, 4, 5, and this is added with x6, 7, 8, 9, 10. Right? So actually our sum has been shortened to something of the sort, that this sum has to be manipulated. Why? Because we already know in terms, like we are talking in terms of the divisibility. So this particular thing will be already divisible by penta 9. That is very obvious, right? So this part is actually gone. So we have to talk about the divisibility of this particular thing. So I am changing the page and writing. So now from here actually we need to ascertain, like we don't have any direct values for this. So I guess we can use some inequality. So what we are going to do is, like, one fundamental thing. Okay. If this thing is actually multiplied by penta 9 and it is divisible by penta 9, there can be two cases. Like not two cases actually, more than two. Either it will be small, it will be equal to, or it will be greater than penta 9. But actually the cases get narrowed somewhere. And somewhere is in the sense that because your capital N was wholly divisible by penta 9, the first 5 digits can't be all 9. Because that will become 9 fives are 45. So the next 5 digits have to be also be equal to penta 9. Okay. Otherwise, like 45, right? So 45 plus, like, not very much number of combinations are present in that sense. Like what I mean to say, your x1, x2, x3, x4, x5, this thing will be actually less than penta 9. I'm explaining this more vividly. You will understand soon. Don't worry. And your x6, 7, 8, 9, 10, this thing is actually also less than penta 9. I'm explaining. So why this thing is being valid? Okay, let's see. Okay, so to explain actually this particular thing, let's take this 5-digit number as A and this as B. Okay, for the time being, I will show you. So our capital N, actually this thing must satisfy capital A plus B equals to penta 9. Now, why is it so? Because actually there were 3 conditions. First condition is that your number has to be divisible by penta 1. Second condition is it is divisible by penta 9. and third condition it is divisible by penta. I'm sorry, not penta 9, only 9. Okay, but in this case actually if we add a plus b equals to penta 9, in this particular case one condition is actually being violated, which is divisibility by 9. This thing will not be divisible by 9 actually. Okay, and why? Because this part has been taken out. If you actually see the calculation, right, if you actually notice this part, you will understand that this x1 x2 x3 x4 x5 into penta 9 being segregated out, this particular thing can't be divisible by 9. So what I actually mean to say is, if we see our digits, okay, to maintain this condition, and even if you actually ignore divisibility by 9 for some time, it will be obviously divisible by penta 9, right? That is universal. Like this sum has to be divisible by penta 9 in this particular region, like this bracket, because whole number was divisible by penta 9. This part has been already found to be divisible, so this has to be divisible. So this it means that a plus b, these two numbers have to be divisible by penta 9, this bracket. So to actually make that suffice, we have to do something, and that is, if I take these digits as xi, you will actually notice this thing, that xi plus of xi plus 5, this will be equal to 9. It has to sum to 9, and I will be varying from your 1 2 3 4 5 up till 5. Okay, this thing has to be valid. Like, you can actually take any combination of, like, not combination, pairs of digits. So you take 0 9, you take 1 8, you take 2 7, you take 6 3 3 6, anything. If this condition is not satisfied, this will be false, and if this is false, capital N's condition will be false and question statement will be false. Okay, it's all related. I hope you can understand. Okay, so actually this thing not only explains our inequality, it actually enables us also to find out the smallest and largest possible numbers, which is actually a very, like, important step for us, because that will partially give us the answer. So if we actually now, if I sum up these two, actually a plus b will be equal to quadra 9, and if you see this, a plus b will be actually less than 2 times penta 9 if I add these two up. Okay, and also guys, one more thing which I could have told you before also, like, very simple thought. Okay, a has to be less than penta 9, and if you ask me why, that is because that x1 x2 x3 x4 x5 can't be equal. You know, any of these digits can't be equal, so how it is penta 9? Okay, I should have said this before, it came to my mind later on. Anyways, like, penta 9 has all nines, so how can it be equal to penta 9? It can't be equal to even 498, 3987, nothing like that. All the digits have to be distinct, so minimum to minimum it can be equal to 98765, both for a and b. Minimum to minimum, it, like, not minimum, the maximum value, these two can be equal to, a and b both can be equal to the maximum value 98765, because this thing is the largest number possible when you keep distinct digits. Okay, that was the condition for the question, so obviously it will be less than penta 9. Okay, easy conclusion. So now actually what we can do is, because 98765 is part of the number, so we can do one thing, like, to find out the largest number will come from here itself. Largest number will be when a is large and maximum possible value of a is 98765, right? And now we also need to keep our this thing, which is this part, these 5 digits also, like, something to keep it maximum. So let's try out. Like, if I take 1 2 3 4 0, no, it's not coming. 1 2 3 4 0 0 1 2 3 4. Yeah, I guess this will be the largest number. 98765 and 0 1 2 3 4. This will be your largest number, I hope. Now actually guys, this particular part, you will have a question in your mind obviously, like, why not 43210? That might have been the largest number, but that is not possible. Why? Because if we write 43210, 9 plus 4 is 13, and that is not allowed as per our condition. Okay, this condition has to be maintained. I have explained to you why. So actually I can what I will do is I will put I equals to 1 2 3 4 5 and make the pairs. So pairs are x1 x6 x2 x7. Next it will be x3 x8. I guess 5 such pairs. This will be x4 x9, and finally you will have x5 x10. These are the possible pairs. Okay, x1 plus x6 has to be equal to 9. Similarly 2 plus 7 9, 3 plus 8 9, 4 plus 9 9, 5 plus 10 has to be 9, in that way. So I hope you can understand. Largest possible number will be 98765 0 1 2 3 4. Like, to find out the largest and smallest possible numbers, we have to maintain two things. One is 98765, the maximum value possible. Second is this. Third is this. Three conditions. Okay. Like, this is a god level question. You can understand, right? Really good question. So in the very similar way, if we try to find out our smallest number also, maintaining these conditions, let's frame it. Okay. So if we actually try to find the smallest number, then one thing that we can do is we can keep the first 5 digits the smallest. Now, first 5 digits can't contain 0, 1, 2, 3, 4, because in that case it will be a 9-digit number. It has to be 10-digit. So if 0, 1, 2, 3, 4 is not possible, next highest will be 1, 0, 2, 3, 4. I mean, this will be the smallest first first 5 digits for capital A possible. So if this is your 1, 0, 2, 3, 4, then I guess the first 5 digits are already with us. Now, accordingly, because they will all sum up to 9, we can put the other 5 digits by summing. So if this is 1, this is 8, 0 meaning 9, 2 meaning 7, 3 meaning 6, and 4 meaning 5. So this is your smallest number. You can see it's very easy, right? You determine the first 5 digits. You take these 5 digits, you determine the next 5 digits. Just like that. Okay. So, and I should also write this thing that x1 can't be equal to 0, because that is not allowed at all. It will become a 9-digit number. Okay. So this was it. Like, the first two options are, I guess, solved, and also first two options are correct. But that's not the end to the question. We have to still find out what are the total number of numbers possible. So actually that is where the main difficulty of the question arises. So let's go on to that. Okay. So guys, what I'm doing is I am taking one standard, okay, and that standard is this thing, x1 not equals to 0. So if we actually take x1 not equals to 0, the first pair possible will be 0, 9 only. That is your, I guess it was x1, x6. This, under the condition x1 not equal to 0, this will be the only possible pair. Because otherwise that number will become a 9-digit number. So this is the only possible pair, right? So we can't do any changes to this. So basically this thing is fixed. So if we leave our 5 pairs, one is gone. So 4 pairs are left. So now I have to do like rearrangement among those 4 pairs. So I'm writing a statement. Remaining 4 pairs of digits. These can be actually assigned to the, like, this can be sort of testing your patience. I am writing statements, you will think why, but please, permutations is a difficult chapter. So whenever I get a permutations question, I know writing statements in maths in JE level is sort of a crime, but I will write statements because otherwise you won't understand. Okay. So remaining 4 pairs of digits can be assigned to the remaining 4 positions. Easy to say. In how many ways? In first half. In 4 factorial ways. Very easy. And one more thing also. Now each, like, if I actually find out the total numbers, like 4 pairs of digits can be rearranged in 4 factorial ways, but In the like pairs, you can also swap in between the digits. So 1 2 power 4 also comes in. And this is 1, so I multiply 1 1. So 4 factorial into 2 power 4, I guess 24 into 16. So this comes out to be 384. Right. And now this is done. But now there is a twist, which I didn't tell you before because I wanted to surprise. Surprising twist is this thing is an exception to this particular problem. Why exception? Because x1 not equals to 0 is a predetermined condition that we have applied and then only we found out this. Okay, but that is not to be actually done. Like the problem setter didn't give us anything. It's logical that the first digit can't be 0, otherwise it will not be a 10 digit number anymore. But as per the problem, we need to first calculate the total number of elements, right? So basically what I'm trying to say is we will find out the total number of elements, which will also contain the exceptional values where x1 is not equal to 0, to find out the like where x1 is equal to 0. Okay, so to actually find out the number of valid ones, we will subtract from the total number this particular thing. So you will get the number of admissible or number of valid numbers. Easy, right? So let's go on to the, I will write total. So total basically including everything, exception and all. It will be, I'm not going into writing statements again. It will be equal to 5 factorial because now we are not considering any exception condition. We are taking all 5 pairs. So 5 factorial times 2 power 5. Right. So 120 into 32. So this thing actually comes out to be, I guess, 12 to the 24 and 36. Okay, 3840. So if this is 3840, then your final answer, that means admissible numbers where your x1 is not equal to 0. This thing will be equal to 3840 into your, I guess, okay, not into, I'm sorry, minus 3840 minus 384. So 3456, right? And guys, one more thing also I actually noticed. This x1 not equals to 0 condition is actually, like I should have said this before in slip of words, I forgot. Actually, this particular case is an exception because x1 not equal to 0, like this particular pair can contain both 0 comma 9 as well as 9 comma 0, right? All pairs can, but the condition is that to be valid, to be a valid 10 digit number with the condition satisfied, the first pair x1 comma x6 can't contain 0 comma 9. So actually I calculated those number of conditions where the first pair is 0 comma 9 and then subtracted it from the original. Okay, I now it is, I hope it is crystal clear. So if we actually go on to our options, I will go on to the options once. So our options say digits in tens place for smallest number is 6. Yeah, it's correct. Digits in tens place for the largest number is 3. Yeah, very correct. And total number of numbers 3, 4, 5, 6. So A, B, C will be the correct answers for this particular question. Okay. I hope you like this question, guys. This was a really good question on permutations. So now we will go on to our second question. Okay, so this is our second question for today. This was the question I actually posted in our poll. So if you have seen it and tried it, very good. If you have still not tried, please do try. I will wait for a few seconds and then start on with the solving. Okay guys, I guess now it's time for us to solve this. So basically, if we look into our question broadly, question A and B are one question, questions C and D are another question. So I guess we can take A and B as one question, whose statement is this part. Like not this part. It is something of the sort, if y equal to f of x is a strictly monotonic function in open A to B with fx not equal to 0, then area bounded by y equal to f of x lines x equal to A and B, y equal to f of c where c belongs to A to B open is minimum when c equals to some dash. Something of that sort. and same is in question number B. And question C and D are another question where the question is if the area bounded by fx equal to x cube by 3 minus x square plus a and lines x equal to 0 and 2 and the x-axis is minimum when a equals to dash 2 by 3 or 28 by 81. So we will solve the questions one by one. First, let's go on to this question and then to this one. Okay, I'm changing the page because I have no space here. So as per our condition in option A and B, some conditions were given. That first is f of x is a strictly monotonic function in open A to open B. So first duty is that we have to construct such a function. Okay, like what I'm trying to actually do is I want to graph this out in a diagram so that you can understand better. So what I'm doing is I'm trying to graph this out, guys. Just a minute, I will draw the graph and then show you. Okay, so guys, this is roughly our graph for this question. And you can see I have marked it out. This is y equals to f of c, f of b, f of, okay, this was, I'm sorry. Is this f of b or f of a? Wait, I will check once. Okay guys, I'm sorry, this is f of a. This is f of b, this is f of c, and this is actually white part, this thing is the curve, and the shaded golden color region is actually the area we need to find. Okay. So this actually like makes the interpretation a bit easier. So if we now want to write down the area in terms of integrals, then it will be integral first is a to c. This will be your f of c minus f of x dx, upper curve minus lower curve. And secondly, what we would have is your integral c to b. This thing would be upper curve f of x here and minus of lower curve f of c dx. So if we actually evaluate this thing, I guess f of x integral is okay, but f of c is a constant, so you will get f of c into x limits a to c, so f of c into c minus a. This will be minus integral a to c f of x dx. Next on you will have your plus of integral c to b. I mean sorry, yeah, it's c to b. F of x dx minus of, again this thing actually you will have it to be f of c times b minus c. So if we actually get this into a more comfortable form, your capital A area is coming out to be 2c minus a plus b times f of c plus integral c to b f of x dx minus integral a to c f of x dx. Okay, that's the expression for capital A. And now I guess we needed to minimize our area, and for that we have to actually differentiate capital A with respect to, now you will ask what will be the variable, because c is what we have to find and it's f of c, so basically dA by dc will be what we will find. Okay, so let's quickly do that. So if we actually take a dA by dc, this thing will come out to be a 2c minus of a plus b, then you will have actually f dash c, and these will be actually converted to your, I guess, 2 times f of c minus of 2 times f of c. Am I correct? I will check. Okay guys, I actually wrote it as 2 times. I guess this will be your f of c minus f of c itself. Why? Because when we apply like not L'Hopital's, Newton-Leibniz rule to that. So actually b is a constant, so it will be differentiated and 0. Now f of c and c, when it is differentiated, it is 1 because the differential is with respect to c. Okay, so f of c minus f of c gets cancelled. So if we actually put this equal to 0, we will get our minimum or maximum value, whatever, like the critical point, c equal to a plus b by 2. This thing is a critical point. Now actually this is pretty, I guess, enough to prove, but still we will see. So for maxima, this is for maxima or minima. We have to see which one. Okay. So let's check this out for which one. So basically, if you see your function f, it's an increasing function, monotonically increasing. which means f dash c, which is a positive number, will be obviously greater than 0. So for c less than of your a plus b by 2, I guess dA by dc will be less than 0, right? And if c greater than a plus b by 2, your dA by dc will be again greater than 0. So very casually we can say that a is minimum when c equal to a plus b by 2. Like this thing was actually very evident from here also, but still I showed you the sign. Okay. So I guess in this particular in between A and B, option A wins and it is correct. B becomes wrong. Okay, so now let's go on to our options C and D and see what question they have. Okay, so this was the information given, and we have to actually, like, if we need to find out the area. Also, one more thing, f of x is like pretty obvious, but still f of x is, it was mentioned, I guess f of x is monotonic in your 0, 2. So what we will do is, let's first differentiate this, because minimum area, so f dash x we need to find. This will be x square minus 2x, which is x into x minus 2. So pretty simply x equal to 0 and 2 come out to be the roots of f dash x. So if the area has to be minimum area, actually for minimum area, x has to be equal to 0 plus 2 by 2 equal to 1. Exactly similar to the previous case, because f dash x is here, like here the two f dash x's are 0, means exactly if this is 0, this is 2, exactly at the midpoint these two areas, like it will be partitioned equally, so minimum area would be at x equal to 1. Hope this is clear. Okay, or I can draw a graph also, exactly if you want. Okay, let's do that. We are studying calculus, so I guess we can draw the curve of this thing also. F dash x is x square minus 2x, which is x into x minus 2, right? So basically at 0 and 2, if f dash x is 0, which means there are horizontal tangents, right? So if there are horizontal tangents, this is 0, and this is 1, and this is 2. So I guess the curve will be something like this here. It will go through 1, again at 2, it will become flat like this somewhat, and then it will go monotonically increasing. Okay, I guess this is it. Okay guys, just a minute. Actually guys, this statement will be not valid in case of our curve, I guess. Okay, strike off this statement. Okay, it's not getting valid in case of our curve, monotonic. It is, okay, wait a minute. It's once decreasing, then increasing. Okay, wait. No. Why did I strike this off? This is correct. Okay, don't strike it. Oh man, I'm sorry. Don't strike this off. Actually, we are considering in between 0 to your 2 open interval, right? So in between that it is actually monotonically decreasing. After 2 it is increasing. No problems. Okay. It's correct. Very well correct. Don't strike this off. So this will be our curve, I guess. Exactly. And if we want to mark out the area we need, then it will be this area. This area is actually the area we need. Okay. And I guess you can understand at these 2 points there will be horizontal tangents. That's why the f dash x has come out to be 0. So I guess f1 is a root. So there is no more problem to find out x cubed by 3 minus x square plus a. And what is a? f1 is equal to 0. So 1 by 3 minus 1 plus a is equal to 0, which means a is equals to 2 by 3. So I guess the correct answer to this is option C, and option D is wrong. So your correct options for this question will be A and C. Okay, and one of you guys actually wrote the correct options in the comments in my poll. So whoever that was, I don't actually remember. Whoever that was, good work. Okay. So guys, I guess This will be the last question for this video. So I hope you like the questions, guys. The permutations question, especially, it was a really good question. Unique. Okay, like these questions actually, the ones that Alan makes are usually very unique. These two, especially in the entire paper, these two, and the first question was unique, but we had done it in our video, so I will not talk about that. So that's it, guys. I guess we can end the video for today. And please do keep supporting. If you have liked my content, once again, a request, please do like, share, and subscribe. And any comments, anything, any doubts, please do ask me out in the comment section. And that's it for today. Thanks for watching.